Today we're going to be talking about how to write an exponential equation from a word problem. As a reminder, the formula for an exponential equation is y equals a times b to the power of x. Okay? So whenever we're looking at our a value, that's always going to be the initial amount, so however much we have at the beginning. The R value is going to be the rate of growth or decay. Okay, and be careful because you see we don't have any R's here in our equation. So we're going to use the R value, okay, to get to our B value. We have to use that. Okay, and also don't forget that normally our R values are going to be percents, for example, 3%. And we're going to want to change that to a decimal. So if we were going to change that to a decimal, that would give us 0.03. So if we're going to change it, we have to move the decimal 2 places to the left. Okay? And then we use our R value to determine the B, and that is going to be our growth or decay factor. Okay? If it is growing, right, and you're going to know if it's growing based off the problem, it's going to give you some words that tell you it's growing or decaying. If it's growing, you're going to take your R value and you're going to add 1. Okay? So for example, that 3% that I just gave you, you would do 1 plus 0.03, and that would give you a B value of 1.03. Okay? If it was a decay, if it told you it's getting smaller, it's shrinking, etc., then you would go ahead and subtract it. So again, going back to that 3%, you would do 1 minus 0.03, which would give us 0.97. Okay, so even though one of them is growing by 3% and one of them is shrinking by 3%, we're going to have different B values. So it's important to read the problem carefully. Okay, if you're asked to solve the problem and you're going to put the X value in that represents it, X is pretty much always going to represent time. Okay, so be on the lookout and you want to make sure that your units are matching. Okay, all of these words, increase, appreciate, invest, those are all going to be our 1 plus R words. That's going to be the growth factors. And then decay, decrease, depreciate, eliminate, that's going to be 1 minus R. Okay, sometimes they don't give you a percent. Sometimes they're not going to give you an R value. They're just going to give you a word that tells you automatically what your B value is. Okay, so if they give you an example that says doubles, you don't have to worry about the R. You will just automatically have a B value of 2. Okay, triples, a B value of 3, 1/2, a B value of 0.5. Okay. Compounded monthly and quarterly are not really about the B value. It just is how you're going to put your exponent. Okay, so if you have compounded monthly, you would put your exponent to a 12 if it was for 1 year, and then you would have to multiply if it was multiple years. Okay, compounded quarterly, you'll do it to the power of 4. Okay, so for example, it says Kristen invested $2,000 into a savings account with a 5% annual interest rate. Okay, so initially at the very beginning, she had $2,000. That's going to be our A value. Then we can see a rate of 5%. So our R is going to be 5%. But don't forget, we can't put percents into our formula. We're going to need to convert that to a decimal. So in order to do that, we'll do 0.05. Okay, so to write the equation y equals a times b to the x power, we have almost everything we need except the b. Okay, now remember, in order to find the b, we add or subtract 1 to the rate that they gave us. And it depends on if it's growing or if it's shrinking. Well, we know invested, okay, means that it is growing. Okay, so what we're going to do to find our b value is 1 plus 0.05, which gives us 1.05. Okay, so y equals 2,000 times 1.05 to the power of x. Okay, then it asks us, well, how much money will she have after 15 years? Okay, now remember, y is representing her total amount of money that she has, and the x is representing the time in years. So when we see that 15 is a year's value, we're going to plug that in for x. Okay, so we take our same equation that we just used, But instead of X, we're going to put 15 because that's how long it has been that her money has been invested. And in order to find the answer, we'll just go to our calculator. We'll go to the calculate screen and we'll type it in how we see it after the equal sign. 2,000 parentheses 1.05 raised to the power of 15. And that gives us 4,157 and 86 cents. We come back, we know that's going to be 4,157 and 86 cents. Okay, we want to make sure that on these problems that it's asking you to solve that you include a label. Our label here will be dollars. Okay, Quinn's new motorcycle is valued at $15,000 with an annual depreciation of 25%. So we can see our A is our initial value at 15,000. Okay, our R, the rate that you can see, is 25%. We're going to have to change that to a decimal so we know, okay, that'll be 0.25. Okay, when it asks us to write our equation, we see, well, it's depreciating, the value is decreasing. So in order to find our B value, we will have to subtract 0.25 from 1, which gives us 0.75. Okay, so our equation will start off with the initial 15,000 times our B value, 0.75, raised to the power of X. Here you can see it says find the value of the motorcycle after 5 years. So we're going to take that same equation that we just used, but we're going to put a 5 in for our X because that's how long the motorcycle has been losing its value. Okay, same thing, we'll go to our calculator, 15,000 parentheses 0.75 raised to the power of 5. You can see now the motorcycle is worth $3,559.57. Okay, $3,559.57. Remember, we got to have our label when it asks us to solve. And our label here is dollars. Okay. For our last example, you can see that the population in Dover in 1987 was 452. Well, that's important because we see initially we had 452 people, but it's doubling every year since then. So this is one of the examples that we do not have an R value. Instead, we can jump directly to our B value because we can see that it is doubling. So our B value will be 2. So the equation will be 452 to the times 2 raised to the power of X. Okay. Now it says find the population in 1995. Well, we're not going to put 1995 in for X. That would give us an outrageously large number. Instead, we're going to say, well, we started in 1987 and now it's 1995. So if we subtract 95 minus 87, that will give us 8 years later. And we're going to use that 8 to plug into our equation. 452 times 2 to the power of 8. Okay, 452 parentheses 2 to the power of 8. That is going to give us our new population. Oops, sorry. $115,712. Okay, 115,712, and we're talking about population. So here our label is people. Okay,